In today's lesson, we're going to be looking at D-type flip-flops. For your starter activity, I want you to think about what the differences of RAM and secondary storage are and their purposes. Try and do a little bit of revision if you can't remember what the differences are. So remember, secondary storage is long-term, whereas RAM actually is volatile. So that data is going to be deleted when the computer's turned off. We can find D-type flip-flops in static RAM. We're going to have a look at how these are actually used to enable temporary storage of data. So remember, static RAM is made up of specialised circuits called D-type flip-flops. D-type flip-flops have two inputs, D and the clock. One of these inputs is slightly different from what we've seen before because it's actually determined by our system clock. Because of this, the input constantly alternates from high to low and back again, so 1, 0, 1, 0. Now, it's very important for us to realise that actually binary is not actually static between 0 and 1. When it changes from a 0 to a 1, all of a sudden an amount of voltage will pass through that logic gate. It's not all of a sudden going to arrive all at the same time to make it on. It's going to have an upward rise. So with a D-type flip-flop, Q, which is our output, will only take the value of D, which is our input, when the clock signal is on the upward rise. And between these moments, Q remains unchanged. So let's try and get our heads around this. This means that the D-type flip-flop can actually store a temporary bit of 1 and 0. If input D changes, Q will keep its value so long as the clock signal isn't changing from 0 to 1 on that upward rise. Here's our first state. The clock is 0 and the D value is 0. That means Q, our output, is 0. Our input has changed to 1, so our input is 1. But the clock still remains at 0, so Q actually remains unchanged at 0. As the clock starts to change and move to 1, you can see as soon as that clock gets to 1, we can see that there's a change. So our output of Q becomes 1. Now remember, the clock alternates between 1 and 0, but while the clock remains 1, our output from D will remain 1. So because we put that value in, Q remains unchanged. It's holding that data value. Even when our clock goes back to 0, because there's not an upward change in the value of the clock, Q remains the same. It's still 1. You can see the input from D again is 1, but the clock is 0, so Q remains unchanged. D is still giving a positive binary of 1. The clock actually changes, there's an upward rising, so Q is set to 1. Well, it was already 1, so it remains 1. You can see D has remained an input 1, but because the clock is actually on 0, the Q keeps its value. The clock returns to 0, D's input returns to 0, it's not an upward rising edge, so Q remains the same. We're still holding that value of 1. Now you can see D is at 0 still, but as the clock changes to 1, Q is set to 0 because the value of D is 0. So you can see how Q has been 1 all that time and all of a sudden it's been changed. The key thing here is to remember that Q will only take D's value when the clock signal is on the upward rise. Between these moments, Q is always unchanged. So this means that Q will only be set or reset when the clock is on an upwards rise. So D-type flip-flops can be therefore stored a temporary bit, and it can store that for as long as it needs to. So here are two key questions that you might be asking. Why do we need the clock to dictate the output of the circuit? And why can't we just input 1 when we want 1 as the output and input 0 when we want 0 as the output? Okay, so the clock input dictates if the output changes, meaning we can have some stability in our circuitry, so it's not changing all the time. Remember, electrical currents are constantly running through the circuitry of a computer. So the output of a D-type flip-flop might too quickly come back to its base, which would cause chaos and cause computer glitches and miscalculations. Sometimes we want to hold that value, and this D-type flip-flop allows us to do that. By having the clock input, which only allows the output to change on its rising edge, it means there's enough time for a signal to pass through the circuit, performing a process without interference. These RAM cells only store data for a fraction of a second, but remember, this is vital as it enables a computer to process and complete a process before the next one begins.